Welcome to aminacademy.com. In Discrete Mathematics, let us discuss about divisibility test. We can check whether a number is divisible by another number without the actual method of division. If a number is completely divisible by another number, then the quotient, we can find some easier method. Since every number is not completely divisible by every other number, such number leave a remainder other than 0. These rules are certain ones which help us to determine the actual divisor of a number just by considering the digits of the number. The division rules from 1 to 13 in maths are explained here. First, divisible by 1. Every number is divisible by 1. Divisibility rule for 1 does not have any conditions because each and every number is divisible by 1. Means every integers is easily divisible by 1. The quotient will come the same, the number. Next, divisibility by 2. If a number is even or a number whose last digit is even number, that is, it ends with 0, 2, 4, 6 and 8, it is always completely divisible by 2. That means every even number is divisible by 2. Divisible by 3. Divisibility rule for 3 states that a number is completely divisible by 3 if the sum of the digit is divisible by 3. For example, suppose consider 4326. 4326. Then the number of digits, sum of the number of digits is 4, 3, 2, 6, which is equal 4 plus 3 is 7, plus 2 9, 9 plus 6 is 15. Then 15 is divisible by 3. So divisible by 3 means 15 is easily divisible by 3. There is no remainder. The remainder is 0. Therefore, we can assume that 4326, that is, we can decide 4326 is divisible by 3. If the last, after adding, further we can add also this one. 1 plus 5 is 6. That is 1 plus 5 is 6. That is 15 is 1 plus 5. Then 6 is a single digit. It is divisible by 3. Divisible by 4. If the last two digits of a number are divisible by 4, then that number is a multiple of 4 and is divisible by 4 completely. For example, consider 87, 32, 56. 87,000, 8,73,256 is divisible by 4 since the last 56 is divisible by 4. That means 56 is divisible by 4, that is last two digit. Therefore, we can say this 8,73,256 is divisible by 4. Then divisibility of 5. If a number ends with 0 or 5, then that number is divisible by 5. It's easy to get the result. Suppose 4525 is ends with 5 and 80,460 ends with 0. Therefore, that is last digit is here 5, last digit is 0. So these numbers are divisible by 5. Divisibility of 6. A number which are divisible by both 2 and 3 are divisible by 6. That is, if the last digit of the given number is even and the sum of the digit is a multiple of 3, then the given number is also a multiple of 6. For example, 5076. 5076, the last digit is 6. Same, 5 plus 0 plus 7 plus 6. 5 plus 0 5 plus 7 is 12. 12 plus 6 is 18. Further, 18 is 1 plus 8, which is equal 1 plus 8 is equal to 9. So which is divisible by 3. So it is last digit is even, so it is an even number which is divisible by 2, as well as addition of digit is divisible by 3. So this number, that is 5076, is divisible by 6. Consider another example. 5 3 2 3. First of all, it is not last digit is not even, so it is not divisible by 2, as well as we can check with for 3, that is 5 plus 3 plus 2 plus 3. 5 plus 3 is 8 plus 2 is 10, 10 plus 3 is 13, which is 1 plus 3 gives 4, which is not divisible by 3. So this 5076 is divisible by 6, but 5323 is not divisible by 6. Now divisibility rule for 7. The rule for divisibility by 7 is a bit complicated, which can be understood by the steps given below. Here consider 1073, we have to check divisible by 7 or not. From the rule stated, the remove 3 from the number and double it. That means it becomes 6. That last digit is 3, remaining number become 10107, and last digit is removed, then is that digit 3 into 2 is 6, so we have to subtract 6 from 107, it becomes 101. Repeating the process one more time, that is 101, last digit is 1, and 1 into 2 is 2, so 10 minus 2 is 8. As 8 is not divisible by 7, hence the number 1073 is not divisible by 7. If the last digit is divisible by 7, then we can say the given number is divisible by 7, otherwise it is not. Divisibility by rule of 8. If the last 3 digits of a number are divisible by 8, then the number is completely divisible by 8. That means you have to take complete number, that is 24,344. Here last 3 digits, consider 344 is divisible by 8. That means if we divide 344 divided by 8, there is no remainder, there is 0 remainder. So the original number, that is 24,344, is also divisible by 8. If last 3 digit is not divisible by 8, that complete number is not divisible by 8. Now divisibility for 9. The rule for divisibility by 9 is similar to divisibility rule by 3. That is, if the sum of the digits of the number is divisible by 9, then the number itself is divisible by 9. For example, 71,019. Consider the addition 7 plus 1 plus 0 plus 1 plus 9, which is equal 7 plus 1 is 8 plus 1 is 9, 9 plus 9 is 18, which gives 1 plus 8 gives 9. So 9 divided by 9. 9 is divisible by 9. So this 71,019 is divisible by 9. Divisibility for 10. Divisibility rule for 10 states that any number whose last digit is 0 is divisible by 10. Any number ending with 0 or zeros, then we can say that number is divisible by 10. Divisibility rule for 11. If the difference of the sum of alternative digits of a number is divisible by 11, then that number is divisible by 11 completely. That is, the rule is sum of digits in odd places minus sum of digits in even places equals 0 or 11. Then 0 or multiple of 11, then we can say it is divisible by 11. Look at this. Here 82,907. Just first of all write that number 82907. Addition of these things gives 8 plus 9 plus 7 is 8 plus 9 is 17. 17 plus 7 is 24. Now this addition equal 2 plus 0. 2 plus 0 gives 2. Then subtracting both is 22. That 22 is divisible by 11. Therefore, the complete number, that is 82,907, is divisible by 11. We'll check one more number with more digits. 170,437. 1,70,437. We'll check it's divisible by 11. So addition of odd digits, 1 plus 0 plus 3. 1 plus 0 plus 3 is equal 4. Then even digits gives 7 plus 4 plus 7 is equal 18. That which is given 7 plus 4 plus 7. So then subtraction is 14. Then 14 is not divisible by 11. So this number, that is 1,70,043,437, is not divisible by 11. Divisible by 12. If the number is divisible by both 3 and 4, then the number is divisible by 12. For example, 42,563. So we'll check for here. We'll check for this is 4. We'll keep it. Now check for 3, that is 4 plus 2. 4 plus 2, 4 plus 2 plus 5 plus 6 plus 4. So total 4 plus 2 is 6 plus 5 is 11. 11 plus 6 is 17 plus 4 is 21, which gives 2 plus 1 equal 3, then 3 divided by 3. So 3 is divisible by 3, so the remainder is 0. Therefore, it is divisible by 3. Check with the last 3 digit 5, 6, 4. We'll check division of by 4. We'll check for 4 last 2 digit is enough. Therefore, then last 64 is 64 divisible by 4. 64, 16. Therefore, no remainder. Here, this number, addition of digit is divisible by 3 and last 2 digit is divisible by 4. Therefore, this number, that is 42,564, is divisible by 12. Divisible by 13. For any given number, to check it is divisible by 13, we have to add 4 times of the last digit of the number to the remaining number and repeat the process until you get 2-digit number. You check if the 2-digit number is divisible by 13 or not. If it is divisible, then the given number is divisible by 13. For example, 2795. The last digit is 5. That multiply with 4, then add with this 3 digit. That is 279 plus 20 is 299. So the procedure is continued. That is 299. Last digit is 9. That 9 is multiplied by 4. 9 into 4 is 36. With remaining, that is 29. 29 plus 36 is 65. That 65 is of course divisible by 13. That is 13 into 5 is 65. Therefore, that number, that is a given number, is 2795 is divisible by 13. We'll check one more number here. 5 lakh 59, sorry, 59,397. We'll check for division for 13. First you have to write 5939 plus 4 into 7. Last digit is multiplied by 4 and that is added with the previous 4 digits. So which is equal 59, 39, 28 is 17, 4, that is 6, 9, 6, 5. Now the procedure is continued like 596 plus 4 into 7, which is equal 596 plus 28. Then it is 14, 1 carries 12, 6. The procedure is continued like 62 plus 4 into 3, which is equal 62 plus 12 is 74. Then 74, we'll check 74 divided by 13. Here we'll check that is the given number is 59397. 59397. So we have to check one more time. 59397, 5939. Then 4 into 7 is 28. Adding is 17. 1 is 695. Here 596 plus 4 into 7 is 28. Addition is 14. 12. 1 carries 6. 62. 4 into 3 is 12. Is 74. 74. 74 divided by 13 is, so why it's not coming. We'll check one more time. 59397, 5939 plus 4 into 7. 4 into 7 is 28. 28, that is 5939 plus 28 is 17. 1 carries 6, 959. 596 into 4 into 7 is 4 into 7 is 28. That addition is 596. That is 6 plus 8 is 14. 1 carries 12. 1 carries 6. 624. That is 62. 4 into 3. No, 4 into 4. 4 into 3. Sorry. 4 into. We are having some wrong here. 4 into 4 is 16. 16 equal 8. This 78. Then is 6. That means 78 is divided by 13 is 6. There is no remainder. That is 78 is divisible by 13. Therefore, we can say 559,397 is divisible by 13. And so far we discussed about divisibility test for 1 to 13. Next, the prime number. What is prime number? Prime number are natural numbers that are divisible by only one and the number itself. In other words, prime number are positive integers greater than 1 with exactly 2 factors. That means 1 and the number itself. Some of the prime numbers included 2, 3, 5, 7, 11, 13 are the prime numbers. Always remember that 1 is neither prime nor composite. Here, these are the prime numbers up to 1 to 100. In between 1 to 100, these are the prime numbers. That means each number have factors, only 2 factors. That means 1 and the number itself. That means we cannot express any prime number more than 2 factors. That means it is only the factor is number 1 and itself. It's a prime numbers. So far we had done about divisibility test and prime numbers. We have done. Please subscribe our YouTube channel.